find the limit if it exists. If the limit does not exist, then find two paths in the xy plane that produce different limit values in order to verify that it doesn't exist. So we have the limit as xy approaches 0, 0 of 3x squared y divided by x to the fourth plus y squared. Well, my suspicion is it doesn't exist. And here's the thing. If it doesn't exist, it's often really easy to prove that it doesn't exist just by approaching the a/b value, in this case 0, 0, on two different paths. But you have to choose the paths wisely. Because if you get the same limit value on both paths, it doesn't show that the limit exists. You'd have to show it on every path, which is impossible. So you can only use this technique to show that a limit doesn't exist. That's really important to understand that. So what's your path? What's your first path going to be? How about just, I think a sensible one to choose would be like, that actually does work. So not to say that that's not sensible, but how about like the x-axis, which would be y equals 0, right? So let's see what happens when y equals 0. Then this guy becomes the limit as x comma 0, right? Y equals 0 approaches 0, 0. Of 3x, okay, y is, I can just plug in 0 there, right? Y is always 0 on this path. And then x to the fourth plus 0 squared. So that's going to turn out to be what? The limit of just, well, yeah, another spoiler. The numerator is 0 all the time, isn't it? Now, it's critical to realize the denominator is not 0 all the time. In fact, the denominator is never 0 because we don't actually let x get to 0 on this path, right? So it's perfectly okay to say that, oh, this is the limit of the constant value 0. So in other words, this is the limit, since this is always 0. This is the limit as x 0 approaches 0, 0 of the constant 0. And of course, we know the limit of the constant is just the constant, which in this case is 0. So on that path, y equals 0, the value of this limit is 0. Would everybody agree with that? So that's how you show your work. Notice I didn't drop the limit symbolism. I showed the limit symbolism in every step. Proper notation is really important at this level, and especially if you go on in math. Doesn't work very well if you try y equals x. I don't remember. Maybe you can get it to work, but a better looking one is when y equals x squared, I think. And I can see it because when I square, or let's use y squared. Let's use x squared. X squared. Because when I square x squared, I get x to the fourth. I can see it's going to work out nicely in the denominator, right? I'll get, if I let y equal x squared, I'll get 2x to the fourth in the denominator. That's kind of a clue. Oh yeah, that might be a good one. So the path y equals x squared turns this limit into the limit as x. Okay, y is x squared, so x comma x squared approaches 0, 0. 3x squared, okay, y is x squared, so I'm just going to replace, in this formula, I'm just going to replace y with x squared. And then x to the fourth plus, okay, y is x squared, so but down here it's going to be x squared squared, right? Everybody buy that? Just plugging in x squared for y in the formula for what we would call f of xy. This is f of xy. Right? And then it works out real nice. Don't drop. The temptation is to drop the limit notation. No, we're not done with it yet. So this becomes what? 3x to the fourth on top, right? Over, this is x to the fourth plus x to the fourth, 2x to the fourth. Would you buy that? I think we're good enough at taking limits now to just go right to the answer, right? So the limit we're taking the constant of as x squared goes to 0, 0 is, it's the limit of a constant 3/2, isn't it? On this path, just on this path, which is 3/2. right? Different values. One path we get 0, the other path we get 3/2. What's your conclusion? You could say, so since I'm pretty sure 0 doesn't equal 3/2, the limit does not exist. The above limit, or just the limit, D and E, does not exist.